So now we have completed our first chapter. We will go to the next chapter, the second chapter, acid, bases and salts. Acid, bases and salts are the three categories of salts, chemical substances we have. Acids, you know that even our our food, even it contains some of the food ingredients. They are either acids, bases are there and salts are there. And the acids which we have in our daily life, you know that citric acid which is present in lemon, then lactic acid which is present in curd. All these are naturally, or acetic acid, that is the vinegar. The dilute solution of acetic acid is vinegar. All are the natural products which contain the acids. Now how the acids got their name? See, it is a story goes up to the alchemists. Alchemists are those chemists who were trying to convert other substances into gold, and when they were doing a lot of experiments, they came across certain substances, new discoveries, then they formulated laws of chemical reactions, etc. And we go back to such a era when this happened. A scientist, he was a drunkard. The full night he drank like a fish. That is, continuously he drank and he left his bottle there and slept. The bottle was open, and in the morning when he got up, you know that drunkards has a problem. They will have that shivering of hands and all. To remove that shivering, they used to take a little bit again in the morning. The hangover, we say the hangover, to remove the hangover, they again have to take a small amount. So in the morning again he was taking from the same bottle which was there open, and he saw that that drink has a sour taste. The alcohol in the night, it was converted to oxidized to acid. So this from the acidus, he said. Acidus means sour in taste. From that came the word acid. So this man, he took the natural products which all have such sour taste, and he gave the name acids to those common substances which are present in sour tasted products. And this acid came into existence, and then we started to study about acids. Now acids, they have common characteristics. Any acid if you take. First one is acids. As I told, acids are sour in taste. They are sour in taste. All acids are sour in taste, but we cannot taste an acid. But any substance which is sour in taste contains an acid. Like lemon, it contains citric acid, which is sour in taste. Tartaric acid present in tomatoes. The ants, you know, the formic acid is present in the ants. So they are sour in taste. Second is, they turn blue litmus to red. They turn blue litmus to red. Red in color. We have a blue litmus paper here. This is a blue litmus paper. Can you see? Blue litmus paper here. Then we will take a test tube, and this is an acid. An acid I have taken. This is hydrochloric acid. I have taken an acid, and I am dipping the blue litmus. See, it turned red. So blue litmus will turn red in acid. Okay, that is another characteristic. Blue litmus turn red. Now, so we can find out whether a substance contains acid by a litmus test. That is, blue litmus will turn red. Now, the metals will react with acids will react with the metals. With the metals, they give hydrogen gas. Hydrogen gas. With the metals, I have taken this is zinc granule. Zinc granule. The zinc granule I am taking in a test tube. Then I am adding acid. This is some concentrated psilocybin because acid is too. So you can see the gas coming out. Bubbles of gas is coming out. Can you see the bubbles of gas coming out? If you collect the gas and burn, it will burn with a pop sound. So metals, the acids will react with the metals to give hydrogen gas. That is one. For example, zinc react with 2HCl to form zinc chloride and hydrogen gas. Zinc chloride and hydrogen gas. Zinc chloride is soluble in water. That's why you cannot see that zinc chloride is forming inside, but hydrogen gas is coming up. You can see the bubbles coming up. Okay, so this is the reaction of acids with the metals. Acids will react with the metal carbonates and bicarbonates to give carbon dioxide gas. With the metal carbonates and bicarbonates, it gives carbon dioxide gas. Carbon dioxide gas. We'll see. I'm taking a test tube. An acid is taken. An acid is taken. Now I will take sodium carbonate. I'll add a little zinc. Carbon dioxide gas is escaping. How will you test this gas? You collect the gas and pass through lime water. Lime water will turn milky. So acids will react with the metal carbonates and bicarbonates to give carbon dioxide gas. These are the general properties of acids. Now you see the acid dilute. This is hydrochloric acid. Hydrochloric acid, you see, it is a colorless gas. It's a liquid, isn't it? It's a colorless liquid. This is sodium hydroxide and alkali base, which is also colorless. Now, if two are kept and without labeling, how will you identify this? Which is an acid and which is a base? For that, there are certain substances. They indicate the presence of an acid or a base by a color change. They indicate the presence of acid and base by a color change. They are called indicators. Such substances are called indicators. So indicators are certain substances, chemical substances actually. They indicate the presence of an acid and a base by a color change. For example, you know, in our daily life, turmeric. Turmeric means manjal. Manjal we soap soap alkaline. Soap red color. That means in alkali it is changing its color to red. Acid color change. Base it will turn to red. Turmeric is an indicator. Indicator is a substance which will show the presence of an acid or a base by a color change. Base color red. We indicator shoe flower, that is hibiscus, chemberati. Chemberati paper it acts like a blue litmus. That's indicator, natural indicators. Now, lab indicators. I will show you certain indicators. They are phenolphthalein and methyl orange. Phenolphthalein. I will take some acid. First, acid I am taking. Then I will add a drop of phenolphthalein solution. Indicator. See, is there any color change? No color change in acid. In acid, it is not showing any color change. So, phenolphthalein. acid, no color. Now we'll see what happens in base. In base, what is happening? This is sodium hydroxide solution, a base. See, I am going to add phenolphthalein indicator. See, it turns pink. So, in acid it is colorless. In base it is pink in color. Okay. Now there is another indicator called methyl orange. Methyl orange. Is an indicator. Methyl orange. See, I will take again acid. I will add phenolphthalein. This is methyl orange indicator. See, it became red in color. Methyl orange became red in color. Orange colored methyl orange, it became red. So in acid, it is red in color. Now we see in base what is happening. I will add the indicator. Is yellow in color, no change. So in base it is yellow in color. In base, yellow. So these are indicators. They indicate the presence of an acid and a base by a color change. Now there are certain other substances. They will indicate the presence of an acid or a base by an odor change. Rather, manam, smell in the change. Indicating whether an acid or a base is present. Then such indicators are called olfactory indicators. They are called olfactory indicators. Olfactory indicators. Indicators, so substances which will give a odor change. For example, vanilla essence. It is an olfactory indicator. Its smell will change in acid and a base. So they are indicators. Now again, so we have now studied acids, which are substances having sour taste. Then they will turn blue litmus to red. They react with the metals to give hydrogen gas, and they react with the metal carbonates to give carbon dioxide gas. These two properties I will go to a little more. They react with the metals to give hydrogen gas. So you see, for example, zinc is reacting with the HCl to give zinc chloride plus hydrogen. So this hydrogen gas, this is called as salt. Now how is a salt formed? By replacing the hydrogen by the metal. The two hydrogen atoms are replaced by zinc, and you got zinc chloride, the salt. The metal will displace hydrogen from acid. So those metals which can displace hydrogen from acid alone can form hydrogen gas. So this is zinc chloride. So if zinc is reacting with the sulfuric acid H2SO4, you will take iron Fe. You will react with H2SO4 to give FeSO4 plus H2. Again, this is salt. The two hydrogen atoms are displaced by one iron atom. So this is FeSO4, the salt. So salt is obtained by displacing hydrogen from acid. So you may see copper. Copper is much less reactive, or copper cannot displace hydrogen from acid because it is less electropositive than hydrogen. So copper cannot displace hydrogen from acid because copper is less electropositive. It cannot displace hydrogen from acid. So all metals will not give this, but almost all metals can give hydrogen gas with the metals. Now, so with acids, all acids also cannot give hydrogen gas. For example, nitric acid. Nitric acid, when you react with the zinc plus HNO3, zinc plus nitric acid will give zinc nitrate plus nitrogen dioxide gas plus water, H2O. You will get zinc nitrate plus nitrogen dioxide gas. You will not get hydrogen gas. The reddish brown gas, nitrogen dioxide gas only you will get, because this nitric acid is a very good oxidizing agent. Instead of displacing hydrogen, nitric acid will act as an oxidizing agent. It oxidizes zinc to zinc nitrate and it is reduced to nitrogen dioxide. So nitric acid cannot give hydrogen gas with metals. But there are certain metals like manganese and magnesium. They react with a dilute nitric acid. Very dilute nitric acid if you use, they will give some quantity of hydrogen gas. That is magnesium and manganese. Other metals, magnesium and manganese, can react with a dilute nitric acid. Then it will give hydrogen gas. So again the percentage of nitric acid must be less than. So these are the reactions of metals with the acids. Now metals, I told you, they react with the metal carbonates and bicarbonates with you carbon dioxide gas. I will do some more examples. For example, sodium carbonate, Na2CO3 plus 2HCl will give NaCl, which is the salt. This is the salt plus carbon dioxide plus water. You will get salt, carbon dioxide and water. So metal carbonate with HCl will give carbon dioxide. Now this is indicators. Indicators are substances which will indicate the presence of an acid or a base by a color change and order change. Color change examples are phenolphthalein, methyl orange, etc., which we use in the lab. In daily life also there are indicators like turmeric. Then we can use hibiscus. I told you the juice from hibiscus, etc., can be used as indicators. So this is what we are going to study today.